Hello, everyone. Thank you for coming this afternoon. My name is Sara Mitchell. I work for AWS as a solutions architect in the financial services team. And I'm here today with Zenon Hanik, who's the CTO from Comic Relief. We're going to talk to you about scaling to your first 10 million users. It's a fairly arbitrary 10 million users, but hopefully it's an ambitious goal for you all. Scaling is a massive topic. We're going to do a fairly sort of wide-reaching, sort of iterative approach to scaling up from one user to 10 million and beyond, and looking at different tools and aspects of the AWS platform that you can use in order to achieve that. If you do a search for scaling on AWS, you'll probably hit Autoscaling first. Now, Autoscaling is a really good service that gives you the ability to deliver elasticity to your applications. We are going to talk about it, but not first. What do we need first? So you've probably seen this slide already today. We're going to talk about the global infrastructure, the scale of the infrastructure that AWS platform provides you with. We have 16 regions currently around the world. Each region is completely independent from each other. And each region is designed to be isolated to achieve fault tolerance and stability across the platform. Within each region, there are availability zones. We currently have 43 availability zones around the globe. And those availability zones are offered on a lower latency links between them, so you can operate services across those availability zones in a different way to how you would architect across multiple regions. And then thirdly, we have many more points of presence, 76 points of presence around the globe. And we'll talk about some of the services that utilize that aspect of the infrastructure as we go on. So it's been a year since London was announced, so the London region is now up and running, which is good for us. You'll see there's some further announced regions at the bottom of this slide, so more to come. So this slide shows you the breadth of the services that are available on the platform. And people get very used to hearing us talk about infrastructure, about compute and storage and networking, which are kind of like the fundamental services that we provide. But we also do a whole range of services higher up the stack. So managed databases, application services around queuing and notification. Many of you will have looked at Lambda as a serverless architecture and be using that. Increasingly now, we're seeing interest in the artificial intelligence services that we offer around Lex and Poly, natural language processing, machine learning capabilities, recognition, our video and image capturing technologies. And all of those technologies all sit as building blocks on the platform. And it's really those building blocks that enable you to build content that you need to deliver. So when we look at those building blocks, some of them are architected and built and provided to you in different ways. So there's some services that are designed to be highly available and fault tolerant. We've built and we manage that aspect of those services ourselves. Amazon S3 is a key example of that. It's a global service offering you 11 nines of durability for your storage. CloudFront and Route 53 we'll talk about in a minute. All of those services you can use and not have to architect in high availability into your usage of those services. There's other services that need you to look at high availability and architect them in a proper way. You need to provide some resiliency as you use those services. So the services on the right there in orange, you need to think about how you're going to position your instances and how you're going to locate them, how you're going to fail over workloads that are running on them. So we're going to start at the very beginning. Day one. Really simple architecture. You've got yourself, you've had a brilliant idea, you're building your website, and you're going to deploy that on a single EC2 instance. You put an IP address in front of it. You access it over our global DNS system, Route 53. And you can build and deploy that and get that ready for going live with your users. You might find as you work through that development process that you're going to take a slightly bigger instance. You're going to be more ambitious of how big that instance is. Maybe you've got some really specific use cases. And we offer a very broad range of instance type now. I'm not even going to try and tell you how many there are. But we offer instance types that are memory optimized for large-scale enterprise class in-memory applications, such as running SAP HANA. We offer graphics-intensive applications, instances. F1 instances offer hardware acceleration, field programmable gate arrays. So that's a big scale of different instance types that you need to think about and pick the right instance type, the right server architecture for your applications. So we can grow the size of our box, we can increase the size of that compute, but eventually we'll hit an endpoint with just running on one instance. And we've got no failover, we've got no redundancy, we've got everything sitting on one instance. So it's fine for one user, but we're going to have to start thinking of some other options. So the first thing to do is to put some state into a database. So we're going to split out some of that application into a database. Now, as you might expect, there's a choice. There's always a choice. So there's a number of database options that we would offer you. And you could start with a self-managed database. You could install that on a compute instance that you've chosen and run and manage that yourself. But what a lot of people are preferring to do is to use a fully managed service. Amazon RDS is a relational database service, fully managed, offering different instance types. So you can have MySQL, you can run Oracle, you can run SQL Server, Postgres, and we will deploy and manage those services for you in a resilient manner on the platform. DynamoDB is a NoSQL database. It's our own implementation of a NoSQL database that we will deploy and manage for you. The third one on that chart there is Amazon Redshift. So that's a petabyte scale data warehousing technology. I'm not going to use that today, but if you're doing that kind of big data applications, then that would be the one to look at for those. Now, the other one that is relatively new service is Amazon Aurora. So that's an implementation of MySQL or Postgres-compatible databases. It scales up to 64 terabytes. It will run 15 read replicas. And we manage continuous incremental backups to S3. And it's replicating across multiple AZs. So we will manage all of that for you. And really, the point of building out Aurora was to really optimize the database for our AWS platform. So it's super fast, it's super performant compared to sort of other similar databases. For this application, we're going to pick a SQL database. There's a lot to be said about NoSQL, and you might want to be using a NoSQL database. We're going to start with a SQL database for fairly ordinary reasons. It's established and well-worn technology. Lots of code exists, lots of communities, books and tools. People understand it. And you really aren't going to break that technology with your first 10 million users unless you've got massive amounts of data. So if you know you're going to need to have really low latency access to that data, it's a lot of non-relational data. There are good reasons for going for a NoSQL database. And we've got some use cases for that later on in the talk. We're going to start, though, with a relational database. And what we've got RDS running in a master and slave configuration. And you'll see I did a little sleight of hand there. I've added in another availability zone now. So I've scaled this out to provide myself with some extra resiliency. I've got my web instances sitting in 2 different availability zones. And you'll see I've also got a load balancer sitting in front of those 2 availability zones. So the Amazon Elastic Load Balancer is, again, one of those managed, highly available services. You can use that, and we will take care of the resiliency and the availability of that service. It's self-healing, it's self-scaling. So it will replace itself if instances fail, and it will scale out to manage the traffic throughput that you need it to have. It can manage session stickiness to your services that it's fronting. It's doing health checks on those services. And it will also integrate with the monitoring and logging on the platform. So all of the logs and the traffic that's going through that ELB will also get pulled out into CloudWatch and allow you to monitor that load balancer. So we've scaled horizontally, we've added more capacity, we've scaled vertically. We're getting up to quite a few users now. Things are going well, the business is going good, lots of people are accessing the site. Let's start really scaling this site out. So in this diagram, we've still got our 2 availability zones. We've got a lot more instances of this application now, but the load balancer is happy directing the traffic across all those instances. You'll see we've added some read replicas into our database layer to remove some contentions on that database. So that's going to just help the database manage all those extra instances. But we can probably do some stuff now to lighten the load on that web layer. Now, what we're going to add in here is CloudFront and S3. So what does this do? CloudFront, again, like Route 53, is a globally distributed service. It's a CDN, so it enables you to cache content in one of those points of presence that exist around the globe. And you can access data that you've stored in S3. So S3 is providing the content for CloudFront. And S3 is our object storage, highly durable, highly scalable. So what are we doing here with these? So let's just look at these individually. So as I say, object-based storage, highly durable, highly scalable. You can put into S3 objects up to 5 terabytes in size, and you can encrypt those objects. And what it's doing is it's providing the content for CloudFront, which is that cache at the edge. So that cache is going to enable users to achieve lower latency and faster response times on their request to that content. Now, interestingly, you can run both dynamic and static content in this configuration. So if you want to run dynamic content, you just set a 0 time to live. CloudFront will then always go back to S3 for that content. And what we find is that you see improved response times and server load times. It increases as the more content you put into it. So if you're running both static and dynamic content, you see even more improvement than just running static content. And the graph at the bottom there shows a customer had collected some data, and they had this kind of spiky, up to about 60 gigabytes per second of load coming through their CloudFront S3 configuration. So they'd used this topology for their solution. And all of that load was absorbed by CloudFront. It managed to just even out all of that load. So it's a really good use case for kind of reducing some of that contention on those web instances. But we can still do a bit more. We can still take some of that load off those web instances. And what we're really trying to do is just to remove how many instances that we need to be running, so we don't have to have quite so much effort going into that web layer. So here we're going to put DynamoDB in place. We're going to use Dynamo for some of our session information. And then we're going to also put some of our common database queries into ElastiCache. So Dynamo is our NoSQL database, so that we talked about that at the beginning. ElastiCache, ElastiCache is a self-healing, scaling managed instance of either Memcached or Redis. So we will deploy and manage the clusters for you, and you just need to sort of configure it and put your data in it. So we're going to use that as a way to kind of, again, make that web tier far more lightweight. So we're finally on to autoscaling. We've taken some of the load off those web tiers, but we still want to be able to have that elasticity in those layers and have automatic resizing of compute clusters. So with autoscaling, you can define minimum and maximum pool sizes. You can use CloudWatch metrics to drive that scaling. So CloudWatch is the engine that's kind of watching what's happening on the instances and noticing when you hit those thresholds of performance or throughput that you want to trigger that scaling activity. And you can also integrate autoscaling with spot instances or on-demand instances. So you can use those different instance types in order to autoscale out. And the charts we use, we often look at Amazon.com for various things. It's a good use case for us, obviously. And so if you look at the traffic throughput on Amazon.com, there's always in November those peaks, as you'd imagine, for at the end of November for Cyber Monday and Black Friday. And we don't want to be provisioned for those peaks all through the month of November. What we want is for our provisioned capacity to really match our requirements, match the use case. And so autoscaling is how you achieve that. So on our site, we could autoscale onto each availability zone. And that would allow each side to scale independently of each other and manage resourcing in each availability zone. But actually what you can also do is just have an auto-scaling group that spans both availability zones. And so that whole layer then will just scale across those availability zones as required. So the next thing we're going to look at is really how can we manage this application. So we're getting up to a lot of users. It's quite a big application. We've got quite a few developers writing code, and we need to know what's going on and manage all of the build processes, the security, all the logging. And we really need to, if we haven't done this already, we're not going to get much further unless we really start to focus on automating a lot of this. So AWS has a big range of automation tools that you can use. Some are high-level services that do a lot of management for you, very convenient, easy to use. Others require some work and some scripting and you to build out some content for yourself. So on this slide here, we've picked off a few. Elastic Beanstalk is a way to provision code, and the platform will manage the provisioning of the required resources to run that code. So you might have a Ruby application. You hand that Ruby application over to Elastic Beanstalk, and it will provision the environment that that application requires. And it's building out that set of containers and managing that cluster of containers for that application to run. OpsWorks is a managed Chef server and a Chef configuration. So you can use your Chef scripts that you've already built or would like to build to manage the lifecycle of your application and the layers of that configuration. And the Chef server is run and managed by us as part of AWS OpsWorks. So it saves you all of that management overhead of that piece of middleware. On the right-hand side, you've got a far more do-it-yourself. So we use CloudFormation for everything in AWS. We use that to automate the provisioning of services, and that's your infrastructure of code layer. So we see a lot of companies now have adopted that as a way to provision in a repeatable way. You store those CloudFormation scripts with your source code. You refresh them as you refresh your source code. It gives you the ability to repeatedly deploy every stack that you need. You can go back to points in time if you need to and redeploy exactly what you deployed at that point in time. So that's just a sort of really good practice to get into. And finally, good old EC2 sitting there at the end of the line. If you want to manage and build everything yourself, you can deploy Chef onto some EC2 instances and continue to run it as you would any other infrastructure. So another part of managing your code is having a way to automate your code pipelines and your code builds and your code deployments. So we have tools in all of those areas. This one, Code Deploy, we're going to look at just briefly here. We'll deploy code into a fleet of EC2 instances. It can manage up tens of thousands of instances. And we'll schedule your updates for you across multiple AZs, so you can manage those updates across multiple instances. It uses YAML as its configuration language, and you can manage it via the CLI or via the management console, but you can really automate all of your deployments through that tool. So the other thing we're going to have to start to think about is monitoring and metrics. How are we going to know what's happening with our application? So we've got all of this auto-scaling going on. We've got things being load balanced across multiple instances. It's vital that you start to pull out key metrics from everything that's happening. You need to be able to see the whole stack. Another thing you can also do is just look at what your customers are saying and start drawing in some of that data and seeing how that impacts how you further enhance and improve your system. And the goal really is to squeeze out as much performance as you can for each component, so each thing is operating as efficiently as possible. There's a whole suite of different levels of metrics that you can have and you can gather on AWS. Some of those you can use third-party tools. There's a whole range of those partners here today, but you can install different tools to monitor and track the behavior of your applications and your infrastructure. But you can also just use the tools and the logging capability that comes with the platform. So CloudWatch and CloudTrail will stream constantly the behavior and the activity that's occurring on the platform, and then you can use different tools to analyze and alert from that data that's coming out. So we've still got this big application that we're building. And for several years now, there's been lots of ways of breaking down these different layers into smaller components. We've talked about SOA for several years. We talk about microservices more recently, stateless microservices. And the reason we talk about these things is that it gives you the ability to be far more granular in how you build and manage, scale, and life cycle each part of your application. And it's really the only way you can sensibly manage a massively scaled application, because we all want to be able to update things more frequently and more reliably. And it's simply too complex if you've got very big applications with very heavy, tightly bound dependencies. So at Amazon, we've spent a lot of time focusing on what's the right size of team, what's the right size of code deploy, and we talk about two-pizza teams. I think there's a session here today all about that, and there's lots you can read up on that. But in order to be able to do that with your application, you need a way of loosely coupling, but also managing those interactions. And again, there's a whole load of building blocks and services on AWS platform that you can use to do that. We've listed some of them here. Notification service and SQS, the queuing service, are both obvious answers to that interaction between these loosely coupled services. But also more recently, we see a lot of people using Lambda as a way to have that sort of event-driven behavior, event-driven activity occurring on the platform. And Lambda's kind of a really nice way of just using small pieces of code to just do a specific function and alert and manage those kind of services and distributed services in that way. So loose coupling will set you free. It's true. What's really nice about loosely coupled services is that you can then use those services and scale those services independently. So certain parts of your application get more use. They can scale out and manage the load better. And it also decouples and reduces some of the contention, because you're managing things within queues, and and things can process those queues as they need to, and as they're free and able to. So as we get to more than 1 million users, as we go on, we're going to keep having to do some of that iterative review of some of these things we've already talked about. We're going to keep reviewing how we're managing our scaling, how we're doing load balancing between tiers. And you'll see we've started now to break some of these web instances up into separate groups. So we're going to autoscale them separately. We've still got CloudWatch in there monitoring everything, managing those scaling events. And we've also got now some SQS in there, managing some messaging, perhaps sending out some emails on our Amazon SES there at the bottom right. So what's next? We're gunning towards 10 million. We're not quite there yet. I guess the next thing really that you're going to start to see is contention on that database. So as you get to 5 million, 10 million users, your database is going to start to sort of have to work quite hard. And so then it's back to tuning. It's good old DB admin's job to start tuning those databases. What can you do to reduce some of that contention on that database? We can put in some federation. We can split up that database into multiple databases so that each one of those is just taking some of the load. Or you can start sharding the database, so you're kind of slicing through shards of that database to kind of spread that load across multiple instances. Adds more complexity into it, so there's some trade-off with that. Now might be a good time to go back to that NoSQL database. Have you got some non-relational data that you can put into a NoSQL database and again, take some of that load, take some of that pressure off the relational database? So, it's been quite quick. I realize that's been quite a whistle-stop tour. Just go through quickly what we have actually talked about. We're going to talk about multiple availability zones. You're going to have to distribute your load for resiliency and reliability. Use self-scaling services. Take advantage of those managed services and allow us to manage the scalability and resiliency of those for you. Put redundancy in at every level. Assume things are going to fail. Architect for that failure, so then you don't come unstuck if something fails that you didn't think about, because you will have already thought about it. We keep going on about using SQL. We like a SQL database, so don't dismiss that as a technology. Caching and automation are going to be important. Good metrics go alongside that automation and splitting things into multiple tiers. And so then you might end up getting to more than 10 million users. Does anything change at that point? Really, it's just fine-tuning. You're going to continue to iterate on your application. You may use more microservices. You may have more finely granular applications. You're probably going to have gone to multi-region architecture at some point in this journey. And you may start to want to build custom solutions for yourself. As you get to a bigger scale, then you start wanting to have some really bespoke use cases. So talking of bespoke use cases, we're going to see what Zinon Hennek has to say about Comic Relief next. Comic Relief obviously have a very unique scaling requirement on Red Nose Day, and he's going to talk to us about their donation platform. Thank you.
Thanks. Just a couple of caveats. I'm Zinon Hennek, I'm CTO of Comic Relief. People expect me to be funny because I'm Comic Relief, so there's not a lot of jokes in this. I apologize about that. The other thing is I don't normally wear a suit, but it kind of makes me feel like a grown-up and makes it look slightly less scary to be up here. For those who don't know what Red Nose Day is, I'm just going to play a short video for you.
Red Nose Day 2017, make some noise!
It's only Ed Shearer.
What?
Happy. Very.
face, Ed Sheeran, I ain't bothered!
And the snail says, that's Michelle. 24 hours of this.
Oh, the cool kids are sitting on the back of the sofa.
So Comic Relief have been going for 31 years. We have a kind of 91% kind of audience recognition within the UK, and we've kind of approaching kind of 1.2 billion pounds that we've raised in this in that time. And that money's come from the great British public. And it used to be that we used to get checks through the post, and now obviously things have moved on a lot from then. What we believe in is a just world free from poverty. Our vision is for a future where we're all safe, healthy, educated, and empowered. And our mission, we try to achieve our mission through the positive change, through the power of entertainment. We funded projects in the UK and abroad, and we funded over 1,800. This is quite an old slide, so that's gone up, and over 309 internationally. Essentially, cloud was made for Comic Relief. That's our kind of traffic profile during our campaign. So our campaigns, we run kind of 6 to 8 week campaigns, kind of all peak with one night of kind of television on BBC One. And so a lot of things go on during those 8 weeks. We have other programming, we have other challenges going on, but fundamentally that one night kind of happens. If we kind of extrapolate that out over the year, that line would almost disappear to nothing, because pretty much nothing else happens. So we have this thing that comes once a year, and within that, we have only the opportunity of that TV show to capture donations. This is what a typical night will look like for us in terms of donations. We'll kind of peak around the 10 o'clock time, and that will be, you know, around kind of 10,000 donations coming in every minute during that time. Within that, the spike is even spikier. So the highest we've seen is around kind of 260 donations coming through in a second. And really, what that means is there's lots of people who have kind of scaling challenges. If you're looking to book tickets to Glastonbury, if it doesn't work, you're going to come back because you want to go to Glastonbury. What we do is we create an incredible TV program that shows some great comedy, attracts the audience in, shows them the need that exists out there in the world through kind of powerful, emotive films, and then allow people to respond to that. If we don't capture that in that moment, people will not come back. So the platform requirements this was in 2011 was the first year that I joined Comic Relief, and I was working on the donations platforms in that time. And we realized that essentially between campaigns, we'd been kind of doubling the amount of people who were moving online. So our platform was getting more and more traffic. And so we realized that with our old platform that we had then, we were just kind of really kind of touching the sides of that. We used to get we used to get 12, 13 technology partners working together to support us on the event. Someone would lend us some kit that would get shipped to a data center in London. And, you know, we'd put those in the racks, and then we start building the application, getting all these groups together to kind of build that. So when we realized we wanted to rebuild it, we wanted to go cloud first. Essentially, the platform serves donation for the public. It also manages a lightweight kind of call center interface, which is essentially the same thing, but has a kind of a call center dialogue that are kind of 10,000 kind of volunteers in kind of over 100 kind of call centers who give their time free to us, can then take calls from the public. Over the kind of 7 hours, we have kind of up to about 600,000 donations come through, and we've built it to handle a peak originally over kind of 500 donations, but we've kind of scaled that down to 300 donations as things have kind of leveled out. A big thing for us was to be out of scope of PCI. So we worked with a company called Ourmikuni, and these were some of the solution patterns that they proposed to us. They proposed to us to go kind of cloud first, and really looked at our problem space. And something that was kind of touched on earlier was kind of statelessness. And I can't emphasize how important this is to simplifying kind of horizontal scaling. If you have to maintain state within your application, it makes things much more complicated. You have to think about your sessions, you have to think about replication, you have to think about all the different kind of availability zones that you have and how you kind of maintain consistency across that. If you're thinking of re-architecting your platform or starting a new Greenfield project, think really, really hard about whether you can make it a completely stateless application, follow full kind of 12-factor app kind of methodology, and make it really properly cloud-native application, because that will simplify things a lot. Another thing that we had was we used kind of eventually consistent pattern. The most important thing for us is that we take the money. Reporting on how much money we've got is important, but it's secondary. So the important things for us is to take the money first and foremost, and then later on we can see how much money we got and what the situation was with each of those individual transactions. So by having an eventually consistent pattern, and I'll be talking about the architecture in slightly more detail in the next slide, you can kind of see, you can really simplify things down. That meant that we didn't need, statelessness means we didn't need a high availability data store. It allowed us to do kind of a proper message queue architecture, which enabled much higher kind of resiliency, and it enabled us to have a completely distributed architecture. Another pattern that we used that history had taught us is that things will fail. If you're going to build on the cloud, something may fail, and you need to make sure that you're prepared for that and build for that. And so build as much as possible redundancy in every layer. So in our application, we've got redundancy at every layer. And then what we're looking at is reducing the time to recovery. If it takes you microseconds, seconds for you to recover a particular part of your application, and it's also not and you also have redundancy there, then it doesn't matter, and that's what we kind of focused on. So this is the kind of architecture slide that we have. So we use a platform as a service technology called Foundry, which allows us to work across multiple kind of infrastructure as a service providers. The first year we ran it in AWS, and this last year we ran AWS and with another kind of cloud provider. Essentially, at the front, we've got a Route 53 kind of does DNS load balancing between 3 different instances we ran this campaign. Each of the instances has all of the applications on it, but through configuration, it decides whether it's just a kind of front-end instance, but also has our kind of reporting shard. Essentially, we have at the top, we've got kind of a presentation layer, which is serving our forms, and then we have a service behind it. It's a microservice. It's a kind of cloud-native app with about 26 different microservices running within that. And essentially, Redis service has workers which push things into Redis queues. And those Redis instances are kind of across multiple AZs, so it pushes into 2 different Redis queues in case one dies. Then you have another worker that picks that up, pushes that what we call a delta, which is a particular instance of a particular transaction. So, for example, the statelessness, that means that you could come to the first shard and see the first form where you put in your name and decide how much you're going to pay. The second form where you kind of put in your credit card details, you could be in a completely different shard. And the final form where you've actually gone through to the payment service provider and brought back the result could be in a different shard. And they all kind of flow down through queues into the kind of donations view API. And each of those queues and workers that are pushing things around are all independent apps, so you can scale them up as and when you need. If you notice a particular queue is kind of filling up a bit quicker and it's not kind of filling, being emptied out by the worker, you can increase the numbers of workers kind of independently just through configuration. And that gets pulled. What's really important behind all of this architecture stuff is about how the way that we develop. So we have continuous delivery, so we're continuously delivering into production. We've actually done production releases during the TV show when we've noticed a small kind of error for 0.01% of our users for a particular kind of Android browser on a particular type of phone. We realized we could fix that. We ran it through our pipeline. All the tests passed, so we pushed that, did a blue-green deploy into one of the shards, and then deployed out to the others. So all the queues work through to the kind of donations view API. When a delta comes into that API, it kind of sees what the delta is, see what other deltas exist for the same kind of user journey, and then puts it all together and decides what needs to be done. We'll push out the data to our data warehouse over at Comic Relief. We'll also be pushing kind of minute kind of totals into our dashboard, which we look at to see how the public are responding to our films, and send an email to a user to say they've had a successful transaction. Then that all gets pushed into a MongoDB, and we report out of that MongoDB. And again, these are all workers that we can increase and decrease. If we were to completely lose the reporting shard, what we can do is just assign one of the other shards or the other instances of our platform and say, you're now going to be the reporting shard, and we can run through rerun all of the kind of stuff that's in the queues and push it down so we can get to the total again. We have, like I said, redundancy in every layer, so we integrate with 4 different payment service providers: PayPal, WorldPay, Stripe, and Braintree, and we load balance between those. We're constantly looking at monitoring and logging, looking at the kind of response time for each of those, and kind of scaling up and scaling down how many we're pushing to that. If anyone's interested in have any kind of further questions on that, you can come and see me. I'm going to be around afterwards. So this is like one part of our estate, and it's our donations application, which takes all of our online donations during the show. We also use AWS for a lot of other things. So all of our websites are been running on AWS for a number of years. These are just some figures about the stuff that runs through during the night of TV. Our fundraising platform, which is a kind of a version, kind of a mixture of kind of Eventbrite and kind of Just Giving, allows people to fundraise on behalf of us, was also running on AWS. And the thing that really kind of worked for us and what working with AWS has given us is it gives you that scalability. Essentially, our model, before, whereas we used to get people to give us physical kits, now with our kind of close partnership with AWS, it allows us to scale up as and when we need to. The speed of development is massively increased. It can be as flexible as we need to do. We run as our regular kind of pipeline. We run automated load tests, so they get scale down automatically and run overnight. Then we run kind of big data load tests. We run a full test and push 600,000 transactions through the application and monitor and check it's going okay and do any stuff that we need to do. I'm very big on kind of infrastructure as code and pipelines. We use Concourse CI, and that's all automated, and the deployment is completely automated, not just of our applications, but of the whole kind of platform. And we can scale, we're kind of constantly ripping down and building up the platform as needed. Security used to be a concern in the cloud. I don't think anyone now consider it seriously to be a concern. You can be insecure in the cloud as much as you could be insecure in your own kind of data center, but there's no way that Comic Relief as a charity could afford the expertise and the kind of the time and effort that kind of AWS puts into kind of security, as long as you follow kind of standards. As part of our pipeline, we've kind of got automated kind of OWASP kind of standard tests that run against security, and obviously then we're obviously making any patching necessary needed. Reduced cost goes without saying, and probably the biggest success factor for me is how boring it is. Red Nose Day 2011, the first year when we had the application, I can genuinely say was the most exciting work experience of my life. And excitement is good in some things, but when you've had kind of weeks and weeks of hard work and sleepless nights, and there's big things coming up, and even the smallest thing goes wrong and you kind of freak out, that's not a good place to be. Whereas now, the night is really, really boring for us. I want to give a shout out to kind of AWS for the support that they've given us. We don't want to need that support. I think the paradigm of kind of the cloud is that you have an API that you call and it's rock solid and it just does what it says, and you do that. But also having the team there to kind of answer questions, and on the night they kind of provide support or on the end of the phone to kind of monitor stuff for us and see if anything goes wrong is very, very useful. Another thing that we did this year with Esri and with our partner Esri, who do GIS software and was supported by AWS, was we had a kind of hack day and had these agencies come in and really look at some problems for us and look at how they could tell stories of what Comic Relief is doing, and we had a really successful kind of hack day, and I'll share some links after this if anyone's interested to see what we managed to do with that. One really interesting one was about looking at a really good visualization of where our money is being spent, the difference that it makes, and kind of following 24 hours around the world and seeing where we've made differences in kind of women's lives. We made a big effort with Esri into looking at really deep down demographic data of kind of anonymizing our donations data and looking kind of really break down them, adding to that kind of demographic data and really looking at where our donations are coming from, and that versus kind of male-female breakdown versus kind of income level breakdown versus all those kind of things to give us a really much better understanding of what our users are doing. We're also doing a kind of a pilot where we fund a lot of other charities and a lot of other projects. So some of these small kind of projects really need some kind of expertise, and we're looking at using our relationship with AWS to provide them with kind of credit and expertise from AWS to help them work, kind of become more effective in the digital space. So before I go, might be some T-shirts over there in the corner if anyone's interested. They're kids' T-shirts ages 1 to 9, so go and grab one before you leave. I'm around after, so please come and see me if you have any questions. Thank you.
Thank you. So thank you, Zenon, for being here. I'm really impressed that you do live updates on Big Nose now. That's really good. Thank you, everyone, for attending. I hope that has been helpful. It's been really interesting to hear what Comic Relief do. They really use us as a partner, and it's a real kind of two-way street. We kind of really work closely with them, and it's a pleasure to do so. So thank you for giving your time. Thank you, everyone. And that's the end of the talk.